Hello everyone, welcome to our presentation, Unlocking Insights, Leveraging Open Source Software for Self-Service Analytics. So my name is Ash, I'm a Senior Data Analyst at Sharesies. I've been at Sharesies for about 2.5 years, and that is the extent of my Python experience. So I'm far from an expert, but I use it every day in what I do.
Hi everyone, I'm Richard Roberts. I've been at Sharesies as a platform developer for 2 years from yesterday actually. Prior to that, I was a professional researcher across visual effects topics, and throughout pretty much my whole adult life, I think I might have been 19 years old when I first used Python. I've been using Python as my bread and butter language. I really love it. And I wasn't sure what I was going to say next. Over to you, Ash.
Nice. Cool. So for those that don't know Sharesies, we are a wealth app. We allow everyday New Zealanders and Australians to buy and sell on the New Zealand, US and AU stock exchanges. We also have a really awesome KiwiSaver scheme, a high interest savings product, and we've also just launched Insure, which is like a car insurance product too. So the vision behind Sharesies is quite simple. So just to create financial empowerment for everyone and to give someone with $5 and $5 million the same money opportunities. So what we're going to cover today. So I'll begin by discussing our journey to building our analytics platform. We'll explain what Theia is and show an example of that. We'll go through the current infrastructure that supports Theia. I'll go through an example of sort of an end-to-end of taking data from a database and visualizing it as a graph. And then Richard will take over and discuss the caching subsystem, the mono repo, and then we'll go through some feedback from some stakeholders. So on our journey to building our in-house data analytics platform, so in early Sharesies time, as we were growing, we initially needed a BI or a business intelligence tool that was out of the box, easy to use, fast, all that kind of stuff that you need when you're starting out and scaling up. Over time, as we grew, the costs were increasing because we wanted everyone to have access to all of our data. So instead of charging per developer, it's charging per end user, and the costs sort of go up quite quickly. We also weren't able to do any sort of advanced analytics or deal with any massive data sets, or massive in terms of our Sharesies. So in early 2022, we found Dash Enterprise. So that is hosted by Plotly. There was a UI for managing apps, which was quite handy, fully Python based, and it was a good fee structure. So that was based on the number of developers, not the number of end users. Over time, we kind of needed more. We struggled to manage the UI, so that kind of stuff. We needed more control on it. Managing the compute was also quite difficult, so we needed something sort of a bit more fit for purpose. And because we had the tools and capabilities in-house to do it, we thought that we would do it ourselves. So in early 2023, we made the decision to move to fully open source Dash. So that was hosted entirely by us, which gives us heaps of flexibility, cheaper running costs, and it was a smaller jump to a new tool because they were both Python based. So in late 2023, we were 100% moved over. It took about 2 weeks of planning, 6 weeks of implementation. We saw a massive increase in the number of people using the apps and as well as performance. And then we also saw a massive decrease in costs. So that decrease was about 80% reduction in costs compared to what we were expecting to pay using Dash Enterprise. So just to kind of quickly summarize the pros and cons of an out-of-the-box solution versus in-house. So the out-of-the-box solution, it's easy, drag and drop, fun, all that kind of stuff. There's a low barrier to entry. Anyone can go in and do it. Unfortunately, it can be quite expensive and there's some limited functionality. The pros of an in-house tool is that it's highly customizable. You can do whatever you like with it as long as it's Python-based. And it was reasonably priced as well. So we pay about $2 per day per app. So that's significantly cheaper. Unfortunately, the cons there is that there is quite a large technical requirement for data analysts. So you almost need to be half a developer as well, because you need to understand how to code, understand how the whole sort of platform fits together as well. So we have called our in-house analytics platform Theia, and that is named after the Greek goddess of sight, vision, and also wisdom. So we thought that was quite a fitting name for it. What you can see here is the internal portal that our staff, Sharesies staff, can log into and view. So we have one app, one dashboard for every single business unit, as well as some overall ones like revenue and acquisition and onboarding and that kind of stuff. So overall, we have about 20 different internal apps, which covers about 90 different pages across all of those apps. So we also have some external apps. One of those is Sharesies Open. So Sharesies Open is a portal that connects companies with Sharesies investors. And essentially what that means is a company on the NZX or ASX is able to log in and view customer trading activity for their company on Sharesies. So I'll show you what that looks like. So cool. So this is the landing page for Sharesies Open. So Sharesies Open, when a company signs up, they're also able to send communications out to retail investors as well. So if you own shares in a company, they are able to send you an email with like the annual results or any kind of thing that retail investors are interested in. And then you're also able to view some insights. So this is what the dashboard looks like. If you're not a data person, don't worry too much about what the sort of the contents is, but this is kind of just to give you a feel on how it looks, what we're able to do, all that kind of stuff, and the interactivity that we've built. So you can see across the top there, we've got some hero metrics, just kind of give the user some really high level numbers that they want to see, sort of the number of people, how much is invested, what their average buying price is, that kind of stuff. We're also able to see over time some investing trends, so the user can go in, change some dates. If they had potentially like an annual report that came out, they wanted to see what the investing trends were over that time, then they're able to do that. And then you can also see a really nice, or what we think is a nice looking line chart. So you can see over time, sort of, are people buying, are people selling, that kind of stuff. And you can see here as an example, there is a large spike there. What we can do is click on day, and then go update report. And then what that does is you can see on the exact day, which was the 17th of July, there was a massive spike in buys, which is great to see for that company. And that could be based on, someone sending out an email communication or something like that. When someone sends out an email, they're like, oh, what was the trading activity that happened after that? They can log in and view that. So it's pretty cool. Just quickly flip back to monthly. Weekly. We're also able to show some nice looking 100% stack bar charts. So you can see over time, are people buying for the first time? Are they selling everything? That kind of stuff. Are they auto investing every week or month or fortnight? That kind of thing. And then looking at the shareholder breakdown as well. This kind of just provides an overview on sort of the types of people that are investing. So we can see the average age compared to like comparison companies and also compared to the Sharesies average. So for this company in particular, you can see that their average age is slightly older than the average Sharesies investor. We can also show some, it's a basic heat map. So we can change the colors, we can change the format, we can change anything that we like in there. So we have full control. And then we also have a nice looking map at the bottom here too. So you're able to hover over the map and see for the number of investors per 1,000 people. So we're able to bring in some external data, join it onto ours, and then understand sort of that per capita number. We'll cover that in a second. So talking about the relevant infrastructure that supports Theia. So on the left, we've got a whole bunch of data sources that we bring through. So our main data source is customers engaging with the Sharesies app. So that's creating, buying, selling, depositing, withdrawing, logging in, doing all that kind of stuff. So that generates quite a lot of data for us. We also have some market-related data, of course, and then we have some external data sources, which I'll talk about in a minute. We also have, so all that data is ingested through from Hevo, transformed using dbt, and then put into Snowflake. So Snowflake is a data warehouse, and that's really like the beast behind Theia. We're able to throw, Richard will discuss it in a minute, but we're able to throw hundreds of queries at it at a time. It can scale up, we can change the roles so that, we're not accidentally surfacing any PII or anything like that, which is really cool. So the data team interact directly with Snowflake, so we can query it ad hoc. So the data team, there's about 6 of us. So there's 3 analysts, 2 data engineers, and a manager. So we're quite a small team for the amount of work that we do. So each of the Theia apps are managed through GitLab, and they're stored in AWS. And then Snowflake builds the file structure underneath each of those apps. So Richard will go through that in heaps more detail in his slides. Access to the apps are managed through Cloudflare, and then of course you can the end users access the app, so they can access it on their desktop, but they can also do it on their mobile if they really want to as well, which is pretty cool. So about 35% of all Sharesies staff view Theia on a monthly basis, which is awesome. Like, we really drive a data-driven culture at Sharesies, and all of our senior leaders use it, on a weekly or monthly basis, which is cool. So now I'm going to go through an example of sort of the end-to-end, so how we get the data into a graph. So just to come back to the infrastructure, this is kind of what it looks like, and I'm just going to focus on just these points here. So like I mentioned before, we have customers generating lots of data for us, but we also have some other data. So Google Sheets is one of them. So for example, if our managers are managing budgets in Google Sheets, then we can bring that through every single day or anytime there's a change, and we can bring that through, which is great. We also have some external data sources. So some of our external clients provide us data on a daily basis, and then we can ingest that and then through the same flow visualize information on a dashboard for them too. So all of that data is ingested through using Hevo. We can set Hevo to run anytime that we like, but generally our most common ones are every 15 minutes or every day. So that gives our users basically near real-time data. So for example, if we're launching a new product and we want to understand how many people are using that new product every 15 minutes, we can see that, which is fantastic. All of that data is then transformed through dbt and then put into Snowflake. So in Snowflake, we have about 9.4 billion rows of data, which to us seems quite a lot. For other companies it may not be, but we have that about across 98 different tables, reporting tables. So Theia queries Snowflake directly, and you'll notice there that there's an arrow going both ways. So we are also able to upload data from Theia into Snowflake and then read that back. So an example of that is if the finance team have some ad hoc revenue that comes through from not customer interactions, then they can go into the finance app, upload a couple lines, that gets put into Snowflake, and then Theia reads that back and then is put into all the different dashboards that reference revenue. So it's really fantastic in that. And then of course you can access the Theia through your device. So this is kind of what it looks like in the code. So on the top left, you've got a very slimline version of what the dashboard looked like. On the bottom left, there's what the layout looks like, and on the right is the callbacks. So I will zoom in a bit in a second, but the way a callback works in this example is, say when I was clicking the update button or changing the toggle, that kind of thing, that triggers a callback. And then a callback has those inputs, does a whole bunch of transformations and calculations, and then it returns two outputs, which is the graph and a dynamic title as well. So for example here, when I change that toggle from weekly to daily, in the layout, it's just a segmented control with an ID of date granularity. We specify the default value to be week. When the callback triggers, it brings through the state of that date granularity, the value. And then when we're grouping the data, we're grouping by that date granularity. So it's just really transforming that data frame. Another example is outputting that figure there. So on the bottom left, we've got a DCC graph, which has the ID there. When the callback is triggered, it's outputting that graph as a figure. And then on the bottom, we've got a function comparison type. So the great thing about this is we're able to use shared code. So anytime that we want to create a graph that looks like that, we have a function that builds all that, does all the colors, that kind of thing. And what we're able to do is just give it the data frame that we want, the granularity, and a couple other things that we want to visualize on that graph. So it's really cool. So on all of our dashboards, we have about 515 different callbacks. So that's an example of one. So that is quite a lot, but it gives all of our end users the interactivity that we want to have. So for example, we don't want to just give a flat dashboard that no one can update, interrogate, drill into, that kind of thing. We want to have that interactivity and get people asking questions. And now Richard will go through the platform.
Okay, so hi again, I'm Richard, back to talk about the platform. So Theia isn't just the data analytics applications themselves, but we moved away from an enterprise product where we needed to build the platform behind it as well. So the platform can be many things. It can be a place where we put features that sit behind the scenes of the applications. I'll talk about one of those today. It can be tooling for developers that make their lives easier. And from a general sense, you're just trying to make things faster, easier, better to work with. That's part of what an enterprise product gives you. And we decided we wanted to do a bit of a DIY platform to make it really fit for purpose for the specifics of the Theia applications. And it's some of those specifics around the platform that I thought I'd present to you today. I have a pointer and it's not clicking. Cool. Does the sidebar bother anyone? I can. Whoa. Okay, cool. All right, feel much better about that. Can be particular about things, sorry. Okay, we had 3 goals with developing a platform, 3 specifics. We wanted a really fast experience for our end users. We're bringing in a lot of data and we wanted that to feel fast, like it was running in your local web browser, like the data was at your fingertips, giving you that intelligence rather than having to wait for it. We wanted the data team, the kind of analysts, to be able to have a simple way of developing this cohesive family of applications together. And we wanted people like me to be able to jump in and collaborate with some of the behind the scenes features. So these are the 3 things that we wanted to put together in a platform. And today I'll talk about 2 aspects of the platform that I think fulfilled those goals. First, I'll talk about the scheduled ahead of time caching subsystem. This is a bit of a zoom into a technical area, but it's what gives the fast performance that we wanted. Then I'm going to switch gears, zoom out a bit, and talk about the mono repository design that we have. This really enables the simplicity of developing a family of applications and enables people like me to jump in and provide some extra support without too much friction. What I'm saying today isn't so much of a tutorial about how to build a platform, but I have wanted to make it informational to show how we had a few principles that we wanted to realize and built a platform around that using pretty much just Python and tools from its ecosystem. And another point is we're a pretty small team. Ash and I primarily collaborated on building this. Okay, so scheduled ahead of time caching subsystem. Going back to the infrastructure page, we dive into this point here. We've got a file system behind the applications. We've got Snowflake, and we're pulling data off Snowflake, putting it into that file system. One of our key concerns was to make it low code. We wanted to minimize the impact on the data team. And we, again, going for performance, specifically, we wanted to give the applications an interactive feel. To give a bit of context to the caching subsystem, I thought I'd break down what a Dash app actually is from a tech stack point of view. So we've got our end users, they're making a request for a page of the application that's picked up by a Flask-based server. We orchestrate that with JUnicorn. And that'll send you back some React components in response to that request. Those React components build up the front-end page that you see in the browser. Some of those contain interactive graphs, and that's done with the Plotly JavaScript engine. And those React components also contain callbacks. That's what enables the interactivity. Okay, so that much is a Dash app that you get out of the box. Auxiliary to that, we've added this ahead of time caching subsystem. Again, pulls data from Snowflake, puts it on the disk, so that the data is as close as possible to where you need it when you're presenting it to users. I'm not going to talk so much about how we built this caching subsystem, but I'll talk about how it's used by the data team. They provide what we call a data function. It's a stub-like function. They provide a reference to a query that's saved on disk, and then they bring in real state from the user interface. This execute function packages that into a proper query, sends it over to Snowflake, gets the response back, formats that as a pandas data frame, saves it to disk. But for some of our largest queries, this can take a really long time to get back. And so this motivates the idea of having a cache subsystem, putting it on disk, so that the next time we want this data, we just need to do a file system read and send that back. We already have the data we need. Functionally instant. But unfortunately, if we don't do anything else, this is still a pretty lackluster experience for an end user. We have a lot of data coming back from these requests. There's a lot of different requests, totaling 21,000 lines of SQL code. And there's hundreds of different states that the user interface can take. And so you often end up in this situation where you're clicking through the application and then you hit something that hasn't been requested before, and then you're sitting around potentially up to a few minutes waiting for that data to come back. And it gives you the experience of walking through a supermarket where just nothing's in stock. It's kind of frustrating. So that motivates having a caching subsystem that gets all the data you need ahead of time. Okay, so to do that, the data team uses these calls to register their data functions to be scheduled. They provide a reference to the data function. They attach a schedule. We use a cron tab syntax for this. That one says every day at 7 a.m. And then they don't provide state from the interface, but list the different states the interface can take that are relevant to this query. We then use Python's AP scheduler and fastness libraries to run this function at the given time regularly for each of those given states on a thread in the background. So it's a non-disruptive way of getting all of the data regularly that we need. Just for some context, we run about 700 queries every day like this at 7 a.m. And then there's others that run more frequently as well. Okay, but now we've got this picture where our end users are requesting something from the application. They're clicking around through the user interface, But you can think of this as behind the scenes. We've got a whole bunch of data specialized to each configuration of the interface, so that it's available for Flask to load and then present back to end users. And then thanks to all the engineering there, that can happen on a really fast loop. Plenty of our smaller graphs can get done in 10, 20 milliseconds, and then some of our largest ones are up to a couple of hundred milliseconds, but it's generally interactive. Okay, and now the experience becomes better. You're walking through the supermarket that's metaphorically full, or everything is there that you could need, the labels are aligned, it's a nice experience. So we've ticked off that first goal of having a fast experience. And I think an interesting high-level thought here is the data team are actually programming two entirely different subsystems when they're creating the code. In the application code, there's subsystem 1, which is users requesting something from the app, you load it from disk and present it back. And then there's the other subsystem where they're programming in the regularity that we're pulling data out of Snowflake and saving it to disk. And it's just kind of interesting from my point of view that the platform lets you do those two subsystems together. Okay, so that's a summary of the caching subsystem and how the data team use it. Again, it's low code. To orchestrate the system, they need only to provide those data functions with the calls to the refresh. And then we get this interactive experience for end users. Thank you. Okay, now I'm going to switch gears and talk about something else. We use a mono-repository design. Talking about repository design seems perhaps incidental in a talk like this, but I think it's a really key aspect of how we've been able to do this project successfully on a short time frame. The data team are really subject matter expertise in telling stories with this whole sea of data we have. It's what gives the intelligence to the end users of the applications. And ideally, I can put together a platform that reduces the time sink they have around things like dependency management, Docker builds, code formatting, managing a Git submodule. If you've ever tried to do that as a day one Python programmer, it can be really a headache. And also, I wanted the ability to jump in a non-disruptive way and change the way that the back behind the scenes works as well. To give a bit of context, this is the way we set up the repository. We've got a folder of applications. In there is other folders, specifically one per application, and they all have the same structure. I'm just going to speed up a little bit, so I'll skim. But there's pairs of files per application, per page in the application. They define the front end and the interactivity between components. There's this folder of SQL, but think of that as instructions for getting the data we need to tell the story. And then there's this cache orchestration file. The data team has some code that they anchor in this shared repository that's linked into all of the app folders. That can be things like changing color schemes across graphs in the applications, but also code that the platform team anchors, things like the implementation of the caching subsystem, some other features. There's deployment, Python configuration, testing, developer commands. But generally the takeaway here is we've got one repository with a family of applications where we're both anchoring different parts and working seamlessly together. You might think of it like this, where the data team is telling a story with data from Snowflake, as well as how to manipulate that into graphical format, metrics, and so on. But the platform team can provide support for orchestrating the server, implementing the backends, not backends, but the underlying features, as well as providing support for standard software engineering tasks. I think this is what's enabled us to collaborate quickly on this project and really make it successful. Another little nice outcome of this is you have a deployment pipeline that's both cost and performance optimal. We've got all the code for the apps in one place, which means we can build a single Docker image containing all of that code, a single installation of all of the dependencies, and then we can upload that to AWS. This means that we've got a set of applications running in production, and they can be versioned against this Docker image, which corresponds one-to-one with changes in the main branch of our repository. So that enables a really simplistic versioning, but also a trivial roll forward and roll backward pattern. Okay, so for the data team, this setup lets them develop a family of applications together in a simplistic way. I can provide support with platform features without interrupting the workflow. I just make a simple MR, and we get optimality in the deployment pipeline. Okay, and to conclude, I think it's remarkable that I've been able to put together, or Ash and I together have been able to put together a platform for business intelligence that gives us the types of things we're really after in a platform. We've been able to do that using Python, tooling from the Python ecosystem. So I hope this part of the talk gives confidence to other people that you can do this with a small team. And I also wanted to call out gratitude to you all for being part of a community that's made that possible. Okay, I'm going to hand back to Ash to conclude the talk.
Cool. Thanks, Richard. So just to kind of summarize the Theia project as a whole, there's lots of different things on the screen in terms of the things that we've managed to achieve. But the biggest one I want to call out there is just we managed to deliver it on time, on budget, and above expectations. And I know probably a lot of us in the room have been working on projects where you don't always get to have all three. You generally have to pick one or two. So really great to get all three, and it was really just a fantastic result. And then we also got some really nice feedback from some of our senior leaders as we implemented this. So we're just really happy that we managed to create a product that was great for both internal and external use for all the people that work at Sharesies. So if you have any questions, you can feel free to email us there, or you can ask us now.
Thanks, Richard. We according to the schedule, we only have 1 minute, but lunch isn't until 12:30.
Okay.
So we can probably take a couple of questions.
Good talk. Thanks, guys. The 2 weeks of planning and 6 weeks of implementation, how much time was spent up front on deciding on like the architectural design? Because it blows me away, to be honest.
Yeah, I think from my perspective, I think we were thinking about how we could do it sort of in the back of our mind for quite some time, but we weren't actually dedicating time to actually do it. Maybe you've got some more comments from the PAS side on. Yeah.
I think because we started with the enterprise product to move away from that, the layer around getting data out of the application from the stock exchange and following it through, that side of it was done. The idea of putting together the platform as a whole, I would say we kind of talked and disagreed about things for 2 weeks and then started to align, and then there was sort of 4 weeks of core implementation from there. That was around the subsystem, the monorepo design. It was the first time for both of us working in that kind of platformy space for a project like this. But yeah, it went fast, but was also quite thorough. But yeah, concretely 6 weeks. 2 weeks was the main planning phase. Does that answer the question? Yeah, cool.
Yeah.
Thanks. I mean, there were plenty of discussions way before that, but yeah.
Does Theia support bypass indication, or does the user of Theia ever ask for like getting the latest fresh data out of the Snowflake for reporting?
Oh, okay. Yeah, we can. So I showed that data function, the stublight function before. You can attach an argument to the decorator that we use. I don't think I showed the decorator, but there's a decorator on it. You can put an argument in there to skip the caching layer. So for the data team, they're just saying something along the lines of skip is equal to true. That will go to Snowflake fresh every time. We use that perhaps sparingly, but yeah, it's possible for sure.
And from the user's perspective as well, like say whenever we want a page to load, we load the default date granularity and the dates and stuff like that. So if someone wants to choose a longer date period, they can. It's just going to take a little bit of time for that data to load. Yeah.
One more.
If you were starting this again tomorrow, but you knew what you knew now, which bits of technology would you not use? Which bits of the stack would you not use? I was particularly curious about React. I do a certain amount of React myself, and yes.
I probably didn't represent this very well, but Dash provides that trio of Flask, Plotly, and React together, and you're just writing Python code that then those 3 libraries work with. So you're actually writing Python to generate the React components. I think that's really useful, and I wouldn't pivot away from that. You know, it's open source and you can hack it how you like. I would still stick by most of what we've done. But to be transparent, I probably dived in with my computer science hat at first. And it's been interesting working with the data team who have the subject matter expertise in analytics. And some things that felt really natural to me weren't always as natural to that team. I'd probably spend more time in the incubation phase, to be honest. I don't know if we would have done anything differently, knowing what we know now. But
worked out pretty well.
Yeah, I think it worked out well. Could have done it a week faster, maybe.